In this video, we're going to look at expanding algebraic expressions, okay? And the word expand in maths means removing the brackets by multiplying the term on the outside with all the terms on the inside of the brackets, okay? So let's have a look at an example to begin with. So just an example that actually involves symbols. So let's say we had a triangle outside of a square plus a star in brackets. So what does expand mean then in this context? So expand means that the triangle is going to multiply the square and the star. So it's actually going to get distributed to both of these symbols. Okay, so what's going to happen is that we'll have the triangle, okay, multiplying the square plus the same triangle multiplying the star, okay? And that would just equal triangle square plus triangle star. I'm going to demonstrate this using counters. In fact, I might just use this part of the board here at the bottom because I'll need a little bit of space, and I'll show you how this works then. So let's say we had a blue counter, okay? So obviously you're not going to copy this down, but just watch this particular demonstration. Let's say we had a blue counter outside of a red counter, okay, plus a green counter, okay, plus a yellow counter. And you're asked to then expand that expression that involves colored counters. Based on the rules, or based on what expand means in maths, it means that the counter on the outside multiplies everything on the inside. So basically these red counters, okay, the red counter, the green counter and the yellow counter are all going to have a blue counter in front of them, in other words. Okay, so that's really the effect of expanding. Okay, so that's really kind of like a long way to sort of show something. Because all of these have a blue counter in common, the reverse of that is what we call factorizing, which we're going to do in another video, not in this particular one. We could just say, well, since blue is the counter that's in common, okay, we don't need to show those ones. We could just put these back inside the brackets. So that's what the brackets actually do. It's a way of summarizing anything that repeats, or something that's repetitive. We can take the thing that repeats and put it on the outside. Okay, moving on. Let's have a look at some more examples. Okay. So example, so this is now part B. Expand 2 outside of 3 plus 4. Now this is just regular numbers, or regular numerals. 3 plus 4 is 7. 7 times 2 is 14. Now would that work then if we applied the rule of expansion? And let's see. So we have 2 times 3. Okay. Plus the 2 multiplies the 4. Okay. Since 2 is in common with the 3 and the 4. So that's equal to 6 plus 8, and that equals 14. So it certainly does work. Now all the others do involve some algebraic term or some pronumeral, but we expand them exactly the same way. Okay, so the 2 is going to multiply the x, okay, and the 2 is going to also multiply the positive y, the plus y. So 2 times positive y or plus y is just plus 2y. Okay, so can you see, if you think back to the counters again, the 2, okay, is the same symbol. Okay, it's in front of the x and it's also in front of the y as well. So you can think of it as the blue counter, okay, one in front of the green counter, so that could represent the x. The red counter could represent the y. Okay, but notice that each one of these has a blue counter in common, so that's like the number 2 here. It's the same symbol, it's the same number that's in common with both. Okay, so part D, x outside of 2 minus y, exactly the same thing. Okay, x times 2, which is just 2x, x times negative y. Okay, so that's how you got to think. X times negative y. So a positive times a negative gives you a negative. So that's going to be negative xy. Okay. Part E, negative 5 times 3x, negative 5 times negative 2y. Okay. So I'll just show you that again. So negative 5, so expanding this, negative 5 times 3x is negative 15x. What about negative 5 times negative 2y? Okay, a negative times a negative gives you a positive. Okay, very, very important to note that. 5 times 2 is 10, and then we have a y on its own there. Part F. Okay, again, we're just doing the same thing over and over, just with different symbols, different pronumerals, different variables. B times 2b. Okay, so b times 2b, so we have a 2. B times b is b squared. B times positive 3 is positive 3b. Okay, so you can see that it's actually quite straightforward, okay, and actually very simple. We have another one here, so I'm just going to change the board now to this one here. Okay, right, there are quite a few examples, but it's good to see all different types. Okay, and that's some of the probably one of the probably the best way to learn maths is to try as many different types of questions as possible. Okay, and they really do you know, so it can be asked in so many different ways. What about part G, where we have 3 terms inside the brackets? Does the same rule apply? So that's like having actually I did the example with the 3 counters, you know, the red, the green, and the yellow counter, and you have a blue counter on the outside. Of course it will work. So 5 times 2x, okay, is 10x. 5 times positive 3 is, or positive 3y, sorry, is positive 15y. 5 times negative 4w. Positive times a negative gives you a negative. Okay, 5 times 4 is 20, and we have a w which is just sitting there doing nothing, so it's just multiplying the w, so we just put the w at the end, and that's it. Okay, part H requires probably a little bit, maybe an extra step, a little bit more work, not too much more though. I wouldn't say it's necessarily any harder, just an extra step. So expand 5 outside of 3x plus 4 plus 2 outside of 2x plus 7. This one's fairly easy, it's all positives. Okay, so 5 times 3x, okay, is equal to 15x. 5 times plus 4, or positive 4, is positive 20, plus 2 times 2x, okay, so positive 2 times positive 2x is 4x. Positive 2 times positive 7 is plus 14. Now we can collect the like terms, so you notice that there's 2 terms, so that involve an x. So 15x plus 4x is 19x, and 20 plus 14 is 34. Okay, last one. 5 outside of 3x minus 4 minus 2 outside of 2x minus 7. Notice it's the same terms. All I've done though is I've turned the positive signs into negative signs or minus signs. But the same process, exactly the same thing. We don't change anything. Don't let the negative signs confuse you. They're no different to positive signs. It just means negative. It means in the other direction. Right? That's all it means. But we still handle them exactly the same way. 5 times 3x, okay, that's equal to 15x. 5 times negative 4 is negative 20. Negative 2 times 2x. Negative 2 times 2x is negative 4x. Negative 2 times negative 7. Okay, negative times a negative gives you a positive. Now we can collect the like terms again. So 15x minus 4x, okay, is 11x. Negative 20, okay, so that negative belongs to the 20. Negative 20 plus 14, okay, is negative 6. So that would be the simplified expansion of part 2. Okay, don't forget please to copy down the lesson notes and make sure that the examples are also copied down. Please let me know if you have any difficulties or any issues, and all the best for your studies.